In this video, we're going to explore the average rate of change of a function. So in the first three problems, we're given a situation here. It says, the temperature of a room in degrees Fahrenheit is modeled by h of t equals 0.5 t plus 1. So there's my function. H is my output, which is the temperature of the room. And then t is my input, which is the time after the thermostat was adjusted against the number of minutes. And what we want to do is find the average rate of change on particular intervals. First things first, I do want to label some key pieces of information here. So for instance, I want to label that this here is my output of the function, and that t is my input of the function. Okay, so the output, the temperature of the room is going to directly depend on the number of minutes after the thermostat was adjusted. We have a formula for the average rate of change, and it will eventually look familiar in that it's just slope. But if you notice the formula, we have h of b minus h of a. Both of those represent output values. So this is my change in output. And it doesn't look like it, but the b and the a values are actually values of t, the values of the input. So in the denominator here, we have the change in input. All right, now what we want to do is find the average rate of change. So we have this interval given to us, and it's worth noting that this is not an ordered pair. Those brackets tell us definitively that that's definitely an interval. So we have two values of inputs. We have the a value, that's our first one here, and then we have our b value, which is this one right here. What we want to do is find the average rate of change on these given intervals and see if we can make some general conclusions. So based on my interval here, I know that this is going to be my b value, and this is my a value. With that information, then, we can pick out what we need to and plug it into the formula. And so we're going to find h of b, so in this case b being 2, we're going to find h of 2, and we're going to subtract from that h of 0, and we're going to divide by 2 minus 0. Now to find h of 2, we're going to take the value of t, which again is 2, and we're going to plug it into the function for t. When I do that, 2 times 2 is 1, and when I add 1, that's going to give me 2. H of 0, I take 0 and I plug into there, and I add 1, and I get 1. So h of 0 is 1, and then I'm going to divide it by 2, minus 0. And so when I simplify that, I'm going to get 2 minus 1, which is 1, and then 2 minus 0 is 2. So my rate of change on the interval from 0 to 2 is 1/2. And it says include units in your answer, and so based on the information you had here, the temperature of the room, degrees Fahrenheit, is our output, and our input is the number of minutes. So it's 1 degrees Fahrenheit for every 2 minutes. If I do the same thing for the interval from 1 to 4, so this being my b value, and this being my a value, I'm going to plug those in. So I'm going to take 4 and plug it in, so h of 4, and then again minus h of 1, and that's divided by 4 and minus 1. Right? Just again, that formula for rate of change, that's the change in output over change in input. H of 4, when we plug it into the h of t function, it will give us 3. H of 1 will give us 1.5. And then, again, that's divided by 4 minus 1. And so when I subtract those, 3 minus 1.5 is 1.5. And divided by 3 ends up actually giving us, when simplified, 1/2, and the same units. wait a minute, we got the same answer for number 2 as we did for number 1. I guarantee you that if we did number 3, we would get the same thing. Here's why I'm confident we would get the same thing. If you take a look here, 1/2, we know that's the same thing as 0.5. Based on our model, that 0.5 is our rate of change of the temperature of the room. And it's a linear model. So it appears that if we find the rate of change for a linear function, it's the same throughout. So we can also do this with a graph. So once again, we have a interval here of 0 to 1. So A is my 0 value, and my 1 is my B value. And so the first thing I want to look for is the value at 0. Again, these are my inputs here, the t-axis. So I'm going to go to 0 on the t-axis and go up, and I get 8. I'm going to do the same thing at 1, so an input of 1, and follow it up till I hit the graph, and there I have a height of 4. So what we're asked to do is find the rate of change. Now, this is the elevator, basically, passing a certain number of floors. What that means is initially we're on the 8th floor, and after 1 minute, we're down to the 4th floor. So we want to find this as a rate of change. So we want to figure out how far, it looks like it's a decreasing line, so we know we should have a negative answer. So going from this height down to this height, this is a -4. And then going from here to here, that's a +1. So our rate of change is the change in the output, that's a -4, divided by the change in the input, which is a 1. So the rate of change would be -4 floors per minute. It's -4 over 1. I don't even need to calculate the other two because I know they're going to be the same because we're dealing with a linear equation. Because the line has the same slope throughout, the rate of change can't change. But that doesn't hold true for every equation. Now, it holds true for linear because any 2 points you pick on that line are going to give you the same slope. But that doesn't work for quadratics. Depending on which points we pick, we might get vastly different lines intersecting that graph. Now, while we can't compute the average rate of change of a quadratic function, we can figure out, we can't compute the rate of change. We can figure out the average rate of change. So this is an example of a quadratic equation where we've got points picked at 0 and 3, and we drew a line through there. What we're going to do next then is take some different points, because I just want to see what's going on with this. If I picked a point at -1, so that's this guy right here, and let's say that point at 0, that's this one right here. If you look at my line that goes through there, that line represents the average rate of change. It's different depending on the values I pick. We could even simplify it a little bit more and go pick the points at 2, 0, and at -2, 0, and hopefully you can see here that that line has a slope of 0. Again, a different slope based on, different rate of change based on whichever points we pick. And the points are going to be found by using that interval. So from 0 to 3, we had a slope of 3. On this graph over here, from -2 to 5, we had a slope of -10 over 7, a rate of change of -10 over 7. So when we do a problem like this on a quadratic, it doesn't really change anything. We're still going to find the value of A, the value of B, and then find f of B minus f of A. So when we have a 4 here for our B value, we're going to find f of 4. Oops, I wrote B. I should have written 4. So f of 4. And then minus f of -2. And then divided by, and this is where we have to be a little bit careful with the negatives, 4 minus -2. And again, at that point, we're going to plug those numbers in. So f of 4 will be 45. F of negative 2 will be 3, so we subtract 3. And all that is divided by 4. And a minus and negative will become a plus 2. So 45 minus 3 is 42. And 4 plus 2 is 6. So our average rate of change is 7. I don't include units because there are no units. It's just giving us the value of a function. And it's the same type of idea when we're looking at a graph. The nice part is they're essentially telling us, hey, look at these inputs. So if we looked at negative 1, 5 as our interval, what we want to do is go to negative 1 on the x. So again, this is my a value. And if I follow negative 1 up, I get 6. And I want to do the same thing at 5. And here I get 0. So I can draw a line that connects those 2 points. I don't know why I didn't switch colors. Let's try that again. So grab a green line here. There we go. All right, pretty close to being a straight line. All right, so what we want to do then is figure out what's our vertical change. How much did we drop? So if we're going from 6 down to 0, so that's a minus 6. And if we're going in the x direction, we're going from negative 1 to 5, that's a plus 6. So our average rate of change is our change in our vertical coordinate, or the output, divided by the change in the horizontal, or the input. And when I simplify that, I get negative 1. So these two values here, again, are your x inputs. Use those to find the heights, and then calculate how far we went up or down, and then how much did we move to the right. And that's how you're going to find average rate of change. It's effectively finding slope, but again, remember that we've used that term rate of change instead of slope.